I'm really excited today because we're doing something a little bit special. We have come up to the KEF Music Gallery in central London, and this is something that KEF have recently introduced, and it's really a little bit different to what a lot of other hi-fi companies are doing. This is a multi-function space, and it's set up for demonstrations, to showcase the brand, to launch new products, and really enable people to experience KEF products at their very, very best. I mentioned new product launches. Well, the main reason we are up here is something really exciting, and that is KEF have got a new product coming out. And it's going to be launched very, very shortly, and we are really, really excited to see and hear it. I've not heard it yet myself, but I know a bit about it, and I think it's going to be something very, very special. So Prathmesh, thank you so much for taking the time to let us speak to you about your new Lux loudspeaker.
As you mentioned, LS50 for us has been quite significant. It's been very, very successful. It is a two-way speaker, and the sound that it delivers has been something that a lot of users have found attractive. And over the years, we've had a lot of demand for a higher performing LS50. Okay. So the same two-way architecture, but more bass, more output, more refinement. That's essentially what Lux is. Okay, and so how have you achieved that? What are the primary differences between Lux and the previous models? The biggest difference between LS50 and the Lux is the integration of the electronics and the driver. So LS50 was already a very highly optimized system. So it's a two-way system that is optimized in all of the aspects of its performance. So to get to that next level, incremental changes to the LS50 would not have been enough. Okay. So with the Lux, we have a whole new foundation of running the speaker, which comes in the form of a current drive amplifier and VECO, our velocity control technology that we debuted with CO.
Yeah, so VECO is fascinating. It's something I really wanted to sort of dig into a little bit. So I've got I think a basic understanding of VECO. Effectively, it allows the loudspeaker to, in real time, understand what it's doing. Is that right?
Yeah, that's it.
How does it do that?
So there are two parts to VECO. The first part is the current drive amplifier that we're using on the LMF driver and the HF on the Lux. What that does and how that's different to a sort of regular or a conventional amplifier is that a conventional amplifier controls the voltage that's delivered to the loudspeaker. And then depending on the impedance of the driver, that determines how much current is drawn. Now that's important because how much a driver moves depends on the current, not the voltage. And the impedance that determines the current changes. Yeah. It changes with frequency, it changes with operating conditions, and if these changes become non-linear, or they non-linearly modulate the current, with a regular amplifier, all of that distortion goes into the acoustic output. It's the distortion that you can hear. So when you control the current with a current amplifier, you're essentially getting rid of all of this current-related distortion. Now that is dramatic, that is a big deal, and it's also not new in a way. We're not the ones who came up with that idea.
I think was there a Philips speaker in the 70s that...
There was, yeah.
Yeah, that had a very primitive but fundamentally similar technology in it.
That's right, yeah. So I think the Philips speaker, or like other speakers as well, have used accelerometers in the past.
Yeah.
There have also been, so that, I suppose that is a commercial implementation. There's also been a lot of academic ideas. A lot of papers published in the 80s that talk about current drive and motional feedback like we have. But despite that, it isn't something that has picked up in popularity. And there may be a number of reasons for this, but I suspect one of them is that it's difficult to get a system like that to work as well as a voltage drive amplifier. Or rather, that a voltage drive system is much more straightforward and easier to develop.
From my fairly limited understanding, what you're doing is you have something, is it within the voice coil that is almost operating a bit like a moving coil cartridge on a turntable, in that you have a coil in a magnet assembly? And
yeah, so it's very, very similar to a loudspeaker motor. Essentially, it works on the same principle of electromagnetic induction as the loudspeaker motor in the first place. The only difference is that with a loudspeaker motor, the input signal causes the voice coil to move, In the case of the sensing coil, because in our implementation it's attached to the primary voice coil, the movement of the voice coil, which is happening during operation anyway, induces a current in the sensing coil.
Right.
And now because the sensing coil is attached to the primary voice coil, it is moving as fast as the primary voice coil. So the induced current we have in that case is proportional to the velocity of the cone, which is why we're calling it a velocity sensor.
Yeah.
That's really important with current drive, because when you are controlling the current going to the loudspeaker, the mechanical resonance of that moving assembly is not damped. With a voltage amplifier, because the impedance rises at resonance, the current drops, and that controls the driver. If you keep the current steady, that drop doesn't come. So that control isn't there. By having a velocity sensor, we're able to sense when that is happening. We know the signal that we're putting in. We know how much the driver is moving in real time. And in real time, we can correct the difference.
And when you say correct the difference, what are you comparing the measurements from the Vico sensor to?
To the current that we're putting in.
Yeah.
So the input signal, with a current amplifier, the input signal determines the current that you're supplying to the driver.
Yeah.
In an ideal system, you want the velocity of the driver to be proportional to that current. But of course, without the negative loop coming from the velocity sensor, that wouldn't be the case.
So it effectively can recognize there's a difference between the two and it can adjust it in real time.
That's it. Yeah. And it's always working in the background. And it's something that's integrated within the system itself. So it isn't the kind of thing that the user needs to set up. There's no calibration. There are no settings to tweak. It's something that we've built into the system. So of course in the form of the sensor, but then also the integration with the amplifier and all of the tuning needed to get the final desired low frequency alignment from the system.
And importantly then, so it's not a form of EQ or DSP, it is correcting the output of the speaker.
That's right.
Yeah.
So it is doing it in the analog domain.
Oh, okay.
So it's embedded within the electronics. The sensor is passive.
Yes.
Because it's built in and it doesn't require any power. It generates a current, which is based on electromagnetic induction.
Yep.
So we have a sensing coil and a sensing motor, and if you move a conductor in a magnetic field, you get a current.
Yeah.
That current goes to the amplifiers directly. That doesn't go first to the DSP, goes straight to the amplifier. We control the signal, the bandwidth of it, the gain of it within the analog electronics itself. And then that goes to the amplifier. The correction happens within the amplification stage in this negative feedback loop.
And it's completely outside of the DSP then?
It's completely outside of the DSP.
It's really complicated stuff, and I guess that's why it's maybe not taken hold in the past. What are the direct benefits to Vico? What will I hear when I'm listening to this speaker?
The biggest advantage of having Vico is the drop in distortion. So because we have a velocity sensor and at low frequencies the velocity is high, we have a really good sensor signal, like a really good signal to noise ratio. We're able to pick it up quite well and able to control the velocity quite well. Then when you come to the mid to high frequencies, that's where the current driving part takes over, because that's the frequencies where you see a lot of current related distortion. It comes from the fact that the voice coil is heating up as you're using the speaker. That increases its impedance, reduces efficiency. You can see a drop in the output.
So the Vico will also be compensating for the physical changes to the drive unit as it's being used.
The current drive mechanism controls the current. So even as the voice coil resistance changes, the current doesn't drop. That's the key thing, is that the current that's being delivered to the driver does not actually depend on the driver anymore. Like it would for a voltage drive amplifier. So this aspect of the voice coil heating up and the efficiency dropping, called thermocompression, is essentially eliminated.
Yeah, it's just removed from the equation.
Yeah, and that's just down to the mechanism of
Fantastic.
The fact that we have a high output impedance from the amplifier, and that controls how much current is drawn into the circuit, rather than the loudspeaker driver, because in the voltage drive case, the output impedance of the amplifier is very low.
Yeah. So obviously Vico's a really fundamental part of this product. Can you tell me something about the Music Integrity Engine?
Sure. So Music Integrity Engine, or MIE, is essentially a blanket term that we use to describe all of our DSP algorithms and DSP processing that's happening inside. So because LS Lux is an active system, all of the signal management is done in DSP. So that includes input-output control. So any of the physical inputs that you use get digitized, come into the DSP, It also takes care of phase correction, which is something that we do to improve phase alignment between the different drive units. It's already much better than a conventional system because of the Uni-Q. But even a point source, once you add a crossover, has some phase distortion because you're changing components of the signal by different amounts and then summing them up. So that adds an amount of phase wrap and phase deviation that you wouldn't see if there wasn't a crossover. The phase correction filter corrects that. So it compensates for that, so you get perfect phase alignment at a point in space. It's based on measurements that we do in the far field, and that applies to listening distances in the far field. Of course, also the crossover is done in the DSP. The subwoofer controls, so turning the sub on and off, the low pass and high pass for integrating the sub is also done in the DSP. And we also have a number of user-controlled EQs. So we have wall mode for controlling the LF difference because of where you place the speaker close to the wall. Desk mode, same thing, but with a desk. And treble trim, which is now a broadband shelf slope filter, which helps you control the treble output of the speaker. In fact, broadband output of the speaker while keeping it smooth because it's a slope, to account for differences in absorption, differences in program material, and things like that. So a number of controls to adapt the sound of Lux to the rooms in which they're used.
And so is there an element of the DSP which is running continually in the background to optimize the loudspeaker, and then alongside that an element of user control like EQ is available?
That's right, yeah. So MIE out of the box is already optimized to work with the system. It runs all the time, so that isn't something that you can tweak. The things that you can tweak are also part of MIE, but they go on top of the DSP crossover.
An additional layer on top.
That's right.
Obviously, this is an evolved Uni-Q driver. I think, is it your 12th gen Uni-Q now? What differences have you had with the Uni-Q drivers over the years?
So, since it's in its 12th generation, that essentially means that it comes with all of the features of the 12th generation platform. So that is things like the tweeter gap damper that we have in the gap around the tweeter to dampen the resonance that happens in that cavity. We also have the cone neck decoupler, which helps reduce the breakup or reduce the effect of the breakup of the LMF driver. It adds some damping and it's attached directly to the cone. Aside from that, each Uni-Q is unique. So the Lux Uni-Q is designed specifically for the Lux.
I didn't know that. Okay, so you design a driver for a speaker?
Yes. Okay. So the way we do that is, in case of the Lux, the driver is based on the LS50 driver. It has a bigger cone, so it now has a 6.5-inch cone as opposed to the 5.25 of the LS50. It also has the flexible decoupling chassis. We first debuted that technology with LS60, where it was also used on the Uni-Q, and the idea for that was to decouple the vibrations of the motor from coupling into the cabinet through a flexible mechanical link, which is built into the chassis itself. And we then used it on Blade, on the Reference, R series with MAT, Q series with MAT. So we adapted that technology several times. But one difference between all of those and Lux is that all of those were three-way Uni-Qs. So the Uni-Q was used for the MF and HF. Here it's a two-way Uni-Q, so we're using it for the low frequencies as well. That means the motor system is bigger, it's heavier, and the mechanical frequency of the resonance of that mass is also lower. So although the technology is the same, the flexible decoupling chassis, the decoupling frequency is much lower. So to achieve that, we have to adapt the geometry. Once again, we have to make the flexible link more compliant, so add more give.
So it has to be able to move further.
And we need to adjust the damping material to suit that frequency, but also the now wider range of temperatures that it has to put up with. Because an LMF motor will get hotter than an MF motor. So that's an example of the type of customization that goes into each Uni-Q.
I didn't realise that there was quite such a difference. You touched on MAT. So can you tell me just a little bit more about that? Because the skeptical part of my mind thinks this is black magic. What is going on? So can you just tell me, just to a normal person, what MAT is doing?
So MAT stands for Metamaterial Absorption Technology. Essentially, it's a name that we've given to a synthetic or rather an engineered absorber that we've made to absorb the rear radiation from the tweeter dome.
Yeah.
So as you can imagine, with a tweeter or any driver for that matter, sound is created by oscillation of a moving body forward and backwards. Everything that comes out from the front is what you hear in the room. But that means there's the same amount of energy going back into the speaker. And with a tweeter, it's particularly essential to deal with that because the tweeter domes are really thin.
Yeah.
So if you have all of the energy going back into the cabinet, reflecting and coming back,
it's going to
onto the
rebound
dome,
back in. Yeah.
it's going to affect the mechanical integrity of that moving circuit, and any deformations to that is what you're going to hear. And it's in our interest to minimize that as much as possible. So what MAT does essentially, it has 32 channels. Each of these channels are quarter wavelength resonators, which means they have a fundamental resonance frequency and its harmonics. At those frequencies, it's able to absorb a lot of energy because the channel is designed in a way that it absorbs that energy or gets excited at that frequency, which means it takes energy away to...
You can't get rid of energy, so it has to dissipate it.
It has to go somewhere.
Understood,
right?
yeah.
And what each of these channels are doing is that they're kind of catching that
Yeah.
energy. So we have 32 channels. Their fundamental frequencies are spaced so that we can cover a wider range smoothly. And then their harmonics will also be spaced. So when you put all of that together, we have near perfect absorption over the entire operating range of the tweeter.
And obviously, a lot of that is dictated by the shape, the physical shape of the MAT. Does the material have any bearing on it?
Not necessarily. So the working mechanism is the length of the tube, which has, the length will have a certain resonance frequency.
Yeah.
So when the length is equal to a quarter of a wavelength at a certain frequency, that structure will resonate at that frequency. So to make sure that we can do that, we want to make sure we have an assembly or a structure that is rigid enough so that it's not adding further resonances because of rattles or deformations that we don't expect.
So you're trying to dissipate the high frequency that's coming back into the body of the loudspeaker while maintaining as rigid a material as possible.
Yeah, so by using an appropriate material so that this fundamental principle continues to work, right? So we don't want to make the MAT assembly so weak that it interferes with the primary purpose. So we have two parts that are molded separately, and then they're put together. There's a layer of foam in between, which adds to the losses. 32 channels, like I mentioned.
Yeah.
And when you put all of that together, we've called it an acoustic black hole because it makes it very relatable, and
absolutely.
like you can understand it instantly. But from a technical point of view, it means that it absorbs, I think it's almost 99% of the energy coming in.
Yeah.
Or sort of from a more practical point of view, it stops that rear radiation from reflecting back onto the dome.
And again, the real world difference that I will hear when I'm listening to the speaker?
It will be in the detail of the treble.
I mean, we've talked obviously quite a bit about what's inside the loudspeaker. Obviously they're absolutely gorgeous. So can you tell me a little bit about the design of the cabinet?
Yeah, of course. So one of the things that stands out instantly when you look at a Lux cabinet is actually the shape of the cabinet. It's very smooth. There are no visible fixings. There isn't a trim ring or anything like that. So it provides a very smooth surface for the sound to radiate off of. Now that's intentional because an ideal loudspeaker cabinet shape is a sphere, right? The reason for that is diffraction. So a sphere minimizes diffraction to an extent where it isn't a problem anymore. Essentially avoids it altogether because there are no discontinuities.
So why aren't all loudspeakers spherical?
Because it's challenging to make a spherical design.
Yeah.
I think it's also a question of taste and how things look. Like loudspeakers have been rectilinear for a very long time, and I think that's the expectation of what they should look like. There are some spherical speakers in the market, but with Lux, that's what we're trying to achieve as well. We're trying to get as close to that acoustic ideal as possible while still being able to satisfy the sculptural sort of organic form that Ross Lovegrove has come up with.
And you can absolutely see the design heritage of the Mu-On and the Mu-3, Mu-7 headphones. The headphones. But you can quite clearly see that there's a a linked heritage to the design of them. What are they actually made of?
That's an interesting question, right? Because to come up with a shape like this, so of course we needed something that would be repeatable and have a high dimensional accuracy, but one of the requirements also was to have something that's really smooth that we can polish and have a gloss finish in. Now, gloss finishes are very unforgiving.
Yeah.
So if you have small bumps or you have sort of blotchy paint jobs or whatever, they become very obvious. So to get this high quality of finish, we had to use an appropriate material. What we've used here is called BMC. It stands for bulk molded compound. It is the same material that we used for the front baffle of the LS50.
Yeah.
And what it is, essentially, it's a glass fiber reinforced composite material. So it has some resins inside, some types of rubbers, and they're reinforced with glass fiber. The benefit of using something like BMC over other moldable materials, the most popular one being plastic, is that it adds a lot of strength. It's a strong material to begin with. So you have a cabinet that's already made out of a strong material. You have a shape that lends itself to some stiffness. On the inside, we have added ribs to the molding. So you have sort of reinforced, locally reinforced areas on the inside as well. And to that, you add the flexible decoupling chassis that I mentioned earlier. That reduces the vibrations from coupling into the cabinet in the first place. So when you put all of these things together, you get a very strong and inert foundation to mount the drivers in.
Yeah.
And now, immediate benefit of doing that, which I feel is maybe slightly less obvious to a layperson, is that the cabinet is already strong enough that you don't need bracing inside.
I was going to ask if it had internal bracing.
We don't need it in this case.
No.
And all of the volume that we save by not having bracing is then used as LF volume, additional LF volume. So, and that adds LF efficiency, which means we can deliver more bass at louder playback levels than we could with the LS50.
They're clearly a KEF loudspeaker, and what would you say are the qualities that define what KEF is trying to do?
I think the focal point of any KEF design is the Uni-Q. So it's been around for a while, since 1988.
Wow. And
of course, over that time, it has changed. We're in the 12th generation now. But that really is the KEF DNA. The idea behind the Uni-Q is to take the acoustic center of the low mid frequency driver in this case and the tweeter and put them at the same point in space, which means we essentially get a single point source throughout the entire audible frequency range. That has huge benefits in terms of imaging, in terms of on and off axis performance, the way the loudspeakers interact with the room. So that distinctly KEF listening experience of having a very wide soundstage, of the speakers being able to disappear or being able to pick out instruments in this sort of three-dimensional soundstage, comes from the directivity control of the Uni-Q. Now to that, you add a cabinet that is designed to support that even more. And you get the kind of diffraction and dispersion performance that is really difficult to find anywhere else. And I think that is what makes it distinctly KEF. So the principle of a good loudspeaker at KEF have remained the same. They don't change across product ranges, all the way from the Muo Bluetooth speaker to the Muons.
Yeah.
What we're trying to achieve is the same thing, but we're able to do it through different platforms. And with Lux, the platform includes the form of the cabinet as well as driver engineering, as well as system engineering, and for the first time, VCO in a ported loudspeaker system.
It's really exciting. It's properly cool. Yeah.
I can see you visibly excited.
Yeah.
That's really helping me.
No, it's brilliant. Thank you so much.